just wanted to welcome everybody to the web meeting today. And of course, we will try our best to provide you as much information as possible. And of course, if you have any questions, we want to make this very interactive, and we want to have all your questions. But at the end, of course, we'll try to answer everything. The main goal of today's webinar is really to provide you an overview of Ethernet and how Ethernet has evolved and how Ethernet is being deployed in the metro area today, and to also tell you how best to test your Metro E network in today's environment. So my name is Tanina. I'm part of an organization called the Solutions Specialist Organization, and we and my colleagues, myself and my colleagues, we each have a specialty. For myself is all Ethernet related, metro and transport. And of course, you probably, maybe some of you have met me, maybe some of you have met our account managers at JDSU. My role is essentially to support them on the technical side. So today I'll be providing you guys the technical overview of the Ethernet basics, and also a little bit of our portables and how to best utilize them. Okay. So just to give you an idea of the support that you have, I myself am located in Canada, and my region and territory is all of Canada and also the Great Lakes area, and then New Jersey, New York. And we also have my colleagues who will be able to support the metro products across the country. Of course, we have Sean Harmon out west, Philip Kazakoff in down south, and Dave Baker as well. And then our TAC, I don't know if you guys know, but it's a free service. They are all engineers located in Germantown, Maryland, and they're available from 8 a.m. to 8 p.m. Eastern, Monday through Friday. And just to give you an overview of the global presence at JDSU, we have 5,000 colleagues in 30 different countries, and of course 88 years of experience in the test and measurement world. And also, we have a few other divisions that I'm going to talk about in a little bit as well. So at JDSU, we not only are providers of portables and test equipment, but we also like to provide you full and complete solutions. We have the division, our division is now called the Network Service Enablement. And the reason for transitioning to this naming is simply because we want to be seen as a solutions provider. And we, of course, have all the field test equipment, the lab test equipment, but also have solutions in order to run everything remotely. We also have two other divisions which are very interesting, and we do leverage all of the technology coming in from that part of our business portfolio. We do something called the anti-counterfeiting, and this is all developed in California. So, for example, the currency, so your dollar bills and the protection, that's all JDSU technology behind that. The holograms on credit cards, and also our CCOP division will take care of all of that, the optics components. So we leverage the laser technology that's developed in that part of the company to use in our test equipment. And of course, the optical components and the communication lasers we're a large provider of optics. So a lot of the optics that you see in your network equipment manufacturers selling, they're actually JDSU optics. So that's also a technology that we leverage. So of course, how do we leverage all of our instruments? Of course, we want to provide a certain solution, global services, and a full-blown solution, like a complete solution for you guys. So what I'm going to do is I'm going to go over the Ethernet fundamentals and test techniques. And just to give you an overview, first of all, the Ethernet overview, IP intro, the quality of service metrics, and of course the test standards. And before I get into that, perhaps you guys have seen most of our product portfolio. We have, of course, the T-BERD family of products, and back in the days, we had the FST 2802. A lot of you guys that I've met recently, I've seen all of our equipment pretty much in a lot of locations. The latest product that we have is the T-BERD 5800. It's a unit that allows you to do all the way from DS1 to 10 gig. The T-BERD 6000 and 8000 are modular platforms that allow you to do both advanced optical diagnostics and also the testing on the Ethernet side. And of course, the HST 3000, that is the oldest portable in terms of Ethernet testers, and it's quite a popular test piece of test equipment. We have over 100,000 of these deployed worldwide, so it's an extremely popular device. But of course, the advanced technologies have allowed us to have, touch screens and all of the newer equipment. So a couple of things to remember is that the navigation process. So one of the things that's great at JDSU and our T-BERD portfolio of products is that all of the GUIs and all of the equipment are identical. So what that means is that if you know how to operate a T-BERD 8000, you'll be able to operate a T-BERD 6000 and a 5800 as well. So it's very simple. So it's very simple to understand the GUI. Of course, number one is just when you would want to load the application that you want to test. Number two is all the setup, and then number four is the test results, and then finally, number three is how to generate the traffic, and then number four are the test results. So very simple. You load the application, you set up your test parameters, you start the traffic, and then you will observe the results. That's pretty much the scheme. Now, one of the things that we recommend, if you have your test equipment with you today, is to reset all your tests to default. So that's very simple. All you would have to do is go into the main page under Tools, and then you have Reset Tests to Defaults, and then you can configure your unit to 10.1.1000 Layer 2 Term P1 mode. Okay, so that's very simple to do. I'm going to just show you guys here. So this is an equipment I'm connected to. Just go to Tools, Reset Tests to Defaults. It will ask you, are you sure? And of course, you'll say Continue. Okay. Now, one of the things we've observed over the years, statistically speaking, very similar problems occur across all the carriers and across all of the countries, actually. So oftentimes what I've heard is the main problem is auto-negotiation related. So one of the things that you'll notice, and I'll explain what this auto-negotiation is, but oftentimes can cause a lot of issues. And also I will explain how you could easily resolve this using our equipment. So let's start off with Ethernet overview and where it started. Started a while back in the 70s in the Xerox building. So what they were looking to do is just interconnect different devices so that they can talk to each other. So that's essentially how Ethernet was developed, mainly for communication within one building. Okay. So So just one of the things to remember in the Ethernet is really the OSI layer model. This model really describes how your information is transported from one end to another end. And you may hear me stop sometimes. I'm getting some chat messages at the same time, so I apologize for that if you hear me stopping during my presentation. But let's go over the OSI layer model. This is a nice abstraction of what is happening from one end to another end and how is traffic being transferred. So I like to compare the transport of traffic very much like transporting yourself from one address to another physically. So for example, let's say I'm living here in Montreal and I want to get to another location and I want to get to, for example, using the highway, get to New York City. So what would I do? In myself, I have a source address, and then the destination address would be the one in New York City. So New York City has a zip code, Montreal has a postcode, and that's very similar to how your data is transported. So in terms of the physical layer, that's just your wire, so that's what's being used, to get there. And then the layer 2, which is the upper layer, is also assigning an address location from one end to another. And then the network layer is assigning IP address so that you can go from a subnetwork to another subnetwork. So similar to, let's say you're going from zip code to another postcode. So that's really what transportation on the Ethernet side is all about, is going from one location to another and then being assigned the proper addressing to get there. And then, of course, you have the upper layer, the transport layer, which also allows you to transfer application traffic, but establishing a connection first before sending that traffic. So really the main 4 layers to remember is the physical layer, which is, your signaling, the data link layer, which is your MAC addressing, network layer, which is IP addressing, and then transport, which is TCP and UDP. Those are the 4 main layers you want to remember, and then I'm going to focus on today. Okay. So in terms of the physical layer, in order to transport Ethernet, there's several ways. Of course, for short distances, a Cat5e is just fine, which is around maximum of 100 meters. And then if you want to go longer distances, of course, optical cables are required. And in that case, you can use pluggable optics, and then someone is saying that they cannot hear me. If somebody cannot hear me, can you let me know on the chat, please? Other person. Okay. So in terms of transporting Ethernet on the fiber, there's several different. Okay, thank you for letting me know. Everybody can hear me. Okay. So in terms of transporting the data on the fiber side, there's several methods and several distances. So one of the things to remember in terms of distances is, for example, an 850 nanometer lambda will allow you to transport data in the short distances. And then there's 1310, 1550, which are for much longer distances. Now, finally, in terms of Ethernet rates, 10-1R base T, that's the standard one, 1 gigi, 10 gigi, and then 40-100 gigi. So those are, of course, the standard. Now, we talked about auto-negotiation a little bit earlier, and I'll explain how this comes into play in terms of the standard rates. And, of course, you have XFPs, which are used for 10 gig, and CFP for 100 gig, and then QSFP plus for 40 gig. A couple of things to remember. If most of us are used to the DS1 world and how syncing is extremely important. So time sync is important in the SONET or, let's say, DS1 world. This is not the case for Ethernet world. All of the equipment can be in different time. It doesn't matter. This is because the traffic is only sent when it's required to, whereas in SONET, this traffic is present at all times in the link. So synchronization is extremely important when you're deploying SONET or DS1. Synchronization not so important when you're deploying Ethernet. And this is an extremely fundamental difference between the two. Another thing to remember is all of these overhead that we're used to in the SONET world, they provide a lot of good information, mainly the alarming information and also the performance information. So for example, latency, jitter, all of that. Now in Ethernet world, there is no such information on the header, and all of the frames actually vary in size. Oops, someone asking me to replay the SFPs. Okay. Okay, so the SFPs, just to repeat, one person was asking me to repeat. So the SFPs, as you know, for short distance, you use 850 nanometer, longer distance 1310, and then 1550. Okay, and the standard rates, of course, 10 over base T, 1 gigi, 10 gigi, 40, 100 gigi. Okay, so if we go back to SONET versus Ethernet, what's very important to remember is, of course, the size difference in data. So when you're testing Ethernet and testing and turning up a circuit with Ethernet, very important to test different frame sizes. So each of the overhead, of course, does not provide you any type of alarming or any type of performance metrics. So it's important, again, to test all of the frame sizes. And I'll explain how we came up with ways to kind of mimic SONET in Ethernet world later on. Another thing to remember in the SONET versus Ethernet world, SONET was designed for voice traffic, so constant bit rate, and traffic is always present on the network, whereas Ethernet is more designed for data traffic, so bursty traffic, and traffic is only sent when it needs to be. Okay, so this is like a huge difference. Of course, today we deploy voice in a data network, and that can cause a lot more different requirements in terms of testing. Another thing to remember, the SONET versus Ethernet, is that it's a point-to-point link. And so, for example, let's say we're going from A to B through C. It will always go through C because the signal is present at all times. Whereas Ethernet, if you have different routers and switches all across, it can take different routes depending on whichever route is best to get you to your destination. So just like whenever we take the highway to get to one place to another, we're going to try to avoid the traffic jam. So the same exact thing happens in Ethernet world. Whenever we want to go from CP1 to CP2, we try to avoid all the congestion. And that is done through the routing and switching tables. They'll decide for us which is the best path to take. So that causes, of course, that adds more complexity to testing your network as opposed to, let's say, for example, SONET, which will use always the same exact path. So how does it operate? Very simple. In Ethernet world, let's say you wanted to go from PC address A to PC address C. So the switch's job is really to inspect that frame and find out what the source address is, find out what the destination address is, and switch it based on those information that it sees. The switch, of course, has to be configured to be forwarding to that address. So for example, if a frame comes in from MAC address A as a source, and then the destination is MAC address C. So the port there that's connected to the MAC address C will know that it needs to forward the frame directly to it. So that's essentially the job of a switch. Okay, so it inspects the source address, destination address, and based on that, we'll send it on to the next hop. Now let's go back to the auto negotiation. So this is extremely important in Ethernet world. The auto negotiation concept is more on the copper side, so not so much on the fiber side. But really what is most important to remember in auto negotiation is that they need to match. So whenever you're connecting your Cat5e cable, if one side is set to auto negotiation, the other side that you're connecting to has to also be set to auto negotiation. And the auto negotiation process is simple. Whatever the maximum, so the largest, most common denominator will be selected. So as an example, let's say one side is 100 meg and 1000 meg capable, and the other side is only capable of doing 100 meg. So the largest common denominator is going to be 100 meg, and they will auto negotiate to 100 meg full duplex. Now, another thing very important to remember is that you want it to always be in full duplex mode, not half duplex. That's when you get errors. So sometimes if one end is set up as auto negotiation, the other end is set up as fixed, it can end up being that one side is half duplex. So that's actually a bad thing. So that's very important to verify the auto negotiation. They have to both match. Another thing to remember is the standard for auto negotiation says that for 1 GigE, there is no concept of half duplex. So technically speaking, all equipment vendors would have to abide by that standard and not allow to have 1 GigE go to half. But this is, of course, not the case. We found that in the field, we've seen equipment that allow you to do a fixed configuration for GigE. So you might see that as well. So that's something to remember. But technically, in standard-wise, 1 GigE should always be full duplex. So on the interface tab of our equipment, in terms of the settings, you will see that in the interface tab, setup auto negotiation settings are there. And of course, we allow you to have that on or off. So you can have that fixed, and then also display which ones you want to use in terms of the configuration. And you can also verify the auto negotiation result directly on the results window. So if I go to my equipment here, okay, so you would go under setup here, okay, on the physical layer, okay, and then there's the auto negotiation parameters, okay. And then of course, if I go back to results, here under, so you can also verify the auto negotiation here. Hold on. Okay, so under Ethernet. Okay, and the auto neg status here. And of course, there's a way to expand this if you wanted to visualize this further in case during the test as well. Okay. Okay. So now I'm going to go back to the Ethernet frame format. This is extremely important. Now, again, if we go back to the concept of going from one location to another, okay, somebody's asking me to go over the transport, the OSI layer model, but I'm just going to go over that briefly. But in this case, so right now we are able, we are in the layer 2, so Ethernet frame format. Whenever we talk about layer 2, you're talking about a frame. Whenever we talk about layer 3, we're talking about a packet. So really, the most important thing to remember is the 6 bytes here, destination MAC, the 6 bytes of source MAC address, the length type, and the data. Now notice the data can go anywhere between 46 and 1500 bytes, and that's why it's very important to test different frame sizes. And of course, another thing to remember is the smaller the frame size, the more stress, the more overhead processing is going to happen to your network equipment. So usually, very important to test the smaller frame, very important to test the larger frame to verify what is the maximum MTU that is actually configured on your equipment. Okay. So 2 things that are important, the destination MAC address, source MAC address, and the size of the frame itself, so the data content itself. And by the way, you may hear something about security. So whenever we do our testing, we always verify the headers. So the headers are the destination MAC address, source MAC address. We don't verify the content of the data. So sometimes, that can become an issue. So the frame sizes can go anywhere between 64 and 1518. Now, another thing to remember is the concept of VLAN tags. So VLAN tags are very important. Let's say, for example, in a single pipe, okay, you want to be able to send multiple customers traffic. And the way to divide all of the frames and the streams is to add a VLAN tag to the header, okay? So what that means is that you're segregating customer traffic virtually using the VLAN tags, which can go anywhere between 0 and 4995 in terms of the numbers, okay? So those are 4 bytes. They also add 4 extra bytes. So let's say, for example, you have a 1518 byte size frame, then it becomes 1522, okay? Jumbo frame size concept, that's just a frame size that's larger than 1518, 1522. We can configure our equipment to go anywhere up to 10,000 byte size frames. And then the frames do tend to get larger and larger when you add more and more VLAN tags, of course, MPLS labeling as well. So the smaller frames are the most stressful on the network equipment. Large frames are the efficient ones, and then testing will typically cover small to large frames. So let's say, for example, you want to test a 64 for sure, and then a 1518 for sure. And of course, maybe 1 or 2 in between. And of course, most of the standards, the original RFC 2544 standard will tell you to test all the frame size because its original purpose was really to stress your network equipment. Okay. So the benefits of having VLAN on a physical pipe: separate the broadcast domains, provide the security, and then operate at layer 2. So of course, operating at layer 2 is the most simplistic way of transporting data. Of course, it's the most inexpensive way, and then less overhead, less configuration on the IP side. So once I talk about the IP, you'll understand how, deploying a layer 2 network is much simpler than deploying a layer 3 network. So the VLAN tag is, if we were to break it down, is divided in 4 different sections. So you have the TPI, the priority, CFI, and the VLAN ID. So the VLAN ID itself, 12 bits. Priority bit, that's very important. In Ethernet world, when we want to prioritize traffic, let's say, for example, voice traffic, that needs to be prioritized, right? So what we would do is we would assign a P-bit value, a priority bit value that's much higher. So the P-bit value for Ethernet is anywhere between 0 and 7, so 8 different priority possible, and the 7 being the highest. Okay. Now you'll hear a lot of the concept of Q and Q, so VLAN stacking. What does that do? So for example, if you have, your customer's VLAN coming in, but you don't want to necessarily care about what VLAN IDs they're using, as a service provider, you can decide to encapsulate that existing traffic onto another VLAN. So that's called 802.1q. That means you have the concept of a C tag and an S tag. So C tag is the customer tag that's coming in. S tag is what you would be adding in as a service provider. So what's nice about that? You just encapsulate it and then you're done. Okay. No need to find out what the customer's VLAN IDs are. Okay. So of course, Ethernet switches, they provide network attachment and to operate at layer 2 of the OSI model. Learn the MAC address by analyzing the source address. Decide when to forward, and then of course buffer the frames when frames are destined to a port. Okay, that's really like a summary of layer 2 switches and their jobs. Now the Ethernet IP tab on the equipment, so on your T-BERDs, it's very simple. We actually put in the frame in there. So it's very graphical. Whatever we just went through in terms of Ethernet framing, that's exactly the same thing that you have on the test equipment. So if you click on, for example, destination address, it will give you the MAC address. Then if you click on VLAN, it will give you the VLAN information. Now, if I go to my equipment, okay, so if I go under Setup and then go to Ethernet, all right, you'll see the options that it tells you, do you want to encapsulate or not? Let's say I want to put VLAN, Q and Q stacked. We allow you to do stacked. What that means is that when you go over 2 sets of VLAN, that's also possible for E and an I environment, which are network-to-network interfaces between different carriers. So you could be one carrier handing off to another, and then they could already be putting 2 tags, and you may want to put another tag on top. So we allow you to do up to 8 layers of tagging in terms of VLAN stacking. Okay. So here, for example, VLAN stack depth allows you to go from anywhere between 3 to 8. Now, if I go back to just a simple single VLAN, and let's look at the VLAN ID, it will always give you a range. So you go from 0 to 4095. Okay, those are the max values. If I go to the priority bit, it will tell you 0 being the lowest, 7 being the highest, and you can choose any that you wish. Now, if you look at the data, it will say external test pattern. So you do have the choice of doing our test packet, which allows you to get the round-trip delay information, or you can use a regular standard BERT as well. Okay. And of course, the most important, destination address, source address. You'll notice that destination has nothing here. So our test equipment will be doing auto discovery, which is really neat because the far end unit doesn't need to be manned. What it allows you to do is basically once you issue a loop-up code, the far end unit will discover it and put itself in loop-up mode. But I'll go into that in a little bit. Okay. Now, the traffic tab. The essential configuration, of course, was, if we make a summary, is the physical side, the auto negotiation. The second is the Ethernet, and then the third is the traffic tab. So what we want to do is, of course, tell the test equipment how much traffic do you want to send. And as you know, the standard rates are 10, 100, 1,000. Now, of course, you can send any other value as well. Oftentimes, the equipment in between your circuit will police the data. So sometimes, let's say a customer is paying for 20 meg. Even though the physical link allows you to do a gigi, the equipment will police it to 20 meg. Okay, so then in that case, what you would do is when you want to test 20 meg, you would just simply put 20 meg in there. You have 2 choices, of course, percentage versus megabits. So if I go into my equipment, and we go into the traffic, okay, so you have 2 choices, percentage versus bit rate. And of course, layer 1 versus layer 2. So this is something important. Layer 1 means you're including all the headers, so it's full line rate. Layer 2 means data rate, which is statistical, meaning you remove the headers and all you have is the information of the data. Okay. Now, layer 1, layer 2, layer 3, layer 4. Okay, so this is what's important to remember. If you look at the layer 1, it contains all of the information that you exchange when you're sending out a frame. So the start frame delimiter, the preamble, destination address, source address. These 2 are removed when you're doing layer 2. At JDSU, all of our equipment, we always provide you layer 1, layer 2, layer 3, and layer 4 stats. So those are just statistical calculations where we remove the headers and we give you the relevant information according to layer 4, layer 3, layer 1, and layer 2. Okay, so this is very important to remember. Now, if we go follow on over to IP network, so the network layer. So the functions of the network layer in the OSI model, how to provide connectionless, unreliable best effort delivery. So IP is connectionless. It just sends traffic as soon as possible. And then, of course, why use IP addresses for routing versus MAC addresses? Now, remember, a packet also contains all of the MAC address information, just that we add a header, which is called the IP header. Okay, so destination MAC address is still there, source MAC MAC address is there, VLAN, length type, and then now you have the IP header. So the IP header contains all of this information, the source IP, destination IP. Why would we do IP? Simple. It's because you want to traverse across different networks, so different subnetworks. So the network layer really relies on the destination address in the IP header to perform the routing. And the routers will inspect that IP header, and based on that, it will forward on to the next router. Okay. So what do they do? Why would we use IP routers? So they resolve these issues of scalability. So you divide the network into multiple broadcast domains, each identified by a different IP network address. So routers interconnect the networks and choose the best path. Okay. So as an example, if you want to go from one pool of address to another pool of address, that's when you need a router. Okay. Okay. So address resolution protocol. This is extremely important. Whenever setting up to do a layer 3 test, this concept of ARPing is extremely important. Okay, so in layer 2 testing, you don't need to worry about the ARP. So the address resolution protocol will associate your MAC address to an IP address. So for example, here you see I'm looking for the physical address of a node whose IP address is the following, right? Then I'm the node you're looking for, and my physical address is that. So a MAC address is a unique identifier to all pieces of equipment on the planet. An IP address is not a unique identifier. It's an identifier based on the network that you're in. So in order to associate and start sending traffic, you need to associate the IP address with that unique identifier, which is the MAC address. So that's essentially what's happening with the ARP. So you'll see that on the test equipment. It will say, for example, ARP done. That's when you know you're ready to send the traffic. Okay. So in layer 3 world, our best friend is, of course, ping and traceroute. So the ping is a slow protocol that allows you to verify if you have connectivity from one end to another. Okay. So everybody's probably used this before, but you use your MS-DOS prompt and you just ping the IP address that you want to connect to. Okay. And there's, of course, public IP addresses and then private IP addresses. So for example, here, if you see here, it says 209. That's Yahoo's IP address. If you see here 192.168, that's an internal IP address to a LAN. That's how you know, depending on the different types of addressing, different classes, you'll know if it's a private behind the firewall or if it's public outside of the firewall. Okay. So this is just an example of what you would see in an HST 3000. So you'll see something saying sending ARP requests for destination, and then you'll see ARP successful, all summary okay. That's when you know you're ready to do a layer 2 test. Okay. So one of the things to remember in Ethernet world is that it's not like in the layer 1 world where you're doing testing, bit error rate testing. So bit error rate testing is the typical type of testing that we run in the physical layer, and it is a very good test for SONET, for example, and for DS1, DS3. Now, in Ethernet world, because the signal is not present at all times, and when you do have a narrowed frame, what happens to it is that it gets dropped. So a bit error rate, the way to make that test successful is to be able to count the errored frames. Whereas in Ethernet, if they come errored, they'll get dropped, which means that you cannot count the actual frames. So the most important test in Ethernet is really frame loss as opposed to the bit error rate. So it's extremely important to test frame loss. Another thing to remember is we are very used to using a hard loop. Now, in Ethernet world, that's actually an invalid test. Why is that? It's because of the functionality of your switch. So what does it do? The switch's job is really to forward your frame from one port to another. So as an example, let's say you're sending traffic, okay, and you put a hard loop out there, and then you have port 1 and port 2. So the table in the switch will say whatever comes into port 1, okay, will get forwarded to port 2. So if the destination is B, it will get forwarded to port 2. Now, if that frame comes back, okay, with that same source address and MAC address, what will happen is that the switch will say, well, I've already forwarded that, so we'll drop it. Okay, so assumption is that B received the frame. So that's extremely invalid test. So the proper way to run an Ethernet loopback test, as opposed to a layer 1 DS1 type of test, is to make sure that the far end unit can actually swap destination address and source address. So when the swapping occurs intelligently, the test set will be able to receive the traffic back to the originating point. So it's simple. Instead of the destination address being A, it now becomes swapped. So that's really the way to run a proper loopback test in the Ethernet world. Same for IP world. You would have to swap both MAC address and IP address. So that's why you need an intelligent device that can provide you a loop by swapping MAC address and IP address. Okay. So really, this is a summary of what you're looking for in terms of testing in each of the layers. Now, if we talked about the physical layer, you would be looking for the optical power measurements, the cable diagnostics, or the auto negotiation. The near-end connectivity, you want to look at the sync, the link active LED summary page. Far-end connectivity, so loop up successful on the layer 2, ARP successful on the layer 3, and then transport testing. So manual traffic tests, RFC 2544, 1564, and 6349. So these are key numbers that everyone needs to remember in terms of testing Ethernet. 2544 being the one that's been around the longest. 1564 is taking on a lot of steam and going forward, so multiple steams testing. And then, of course, the most relevant to our world today, especially with LTE being deployed and applications being used more frequent, and bursty applications, 6349 is the layer 4 testing. So now if we look at the physical layer in terms of the types of fiber, multi-mode characteristics. So this is just like a brief overview of what you're going to see in the fiber side, multi-mode characteristics, and then single-mode characteristics. And you'll see that it's very important to make sure that you're using the proper cable to the proper optics. So if you have an 850 nanometer cable, it really should be that orange cable or that turquoise. If you have a single-mode optic, which is a 1310 nanometer, the yellow cable has to be used. Okay, so they are very different. So you cannot connect a multi-mode to a single mode. Okay, I've seen some scenarios where you could connect different core size cable, multi-mode, blah, blah, blah. However, but you might experience some issues. So we always recommend use the proper cable with the proper optics. Okay. Another thing that's extremely, extremely important for higher speed testing is making sure that you inspect before you connect. So what happens is very bad. When you have dirt consistently, it can cause, it's actually the #1 source of troubleshooting in optical networks. So very important to always inspect your fiber before connecting it. Okay. Now, let's talk about the electrical cable diagnostics versus the optical power level. So the cable diagnostics on just your Cat5B is going to be, for example, if you have shorts, open, that kind of testing is actually available on board the units as well. So optical, that's in terms of the copper testing. Of course, you have the optical power level testing as well, and that's just verifying if the signal is present, if the dB is right. Okay. So one of the things, like we said, inspect before you connect. Extremely important, not just to inspect your fiber, but also the bulkhead. Okay. We have a lot of tools for this. We have something called the P5000i. This is a USB-based microscope that can be connected to any of the T-BERDs or your laptop, and we even have an iPhone app for that as well. So it's extremely user-friendly, and also we're the only ones to have a nice pass-fail analysis based on the IEC standard. What that means is that essentially when you plug it in, it will tell you based on the zones whether it's considered to be clean or unclean fiber. You would not have to guess whether it's clean or not. It will just tell you. So, of course, if you don't want to fire up a unit and you want to use your laptop, that's also available. And of course, we have the most amount of tips you can possibly imagine as well. Okay, so this is the IEC standard acceptance criteria. I'm not going to go into details into that, but really the most important is your core. So as long as the core has to be pristine, and the rest, of course, based on the criteria, you'll know whether it's clean or dirty. Okay, and this is also available on your HST 3000. If you have that, if you have the color one, you can also plug in our P5000i into the HST 3000. Okay, and of course the T-BERD fiber inspection is also extremely simple. As soon as you plug it in, you'll see the microscope appear on the top, and when you click on it, it will turn yellow, and then right away test your fiber. Okay, so in terms of the physical layer, what we're looking for in summary is half duplex, full duplex, flow control on or off. Okay, and then link is active but no data is sent. So this is the first thing you want to verify if all of that is connected. Okay. Sorry guys, I'm also getting questions at the same time, so I'm going to answer everybody at the end. Okay. So in terms of the near-end connectivity, most likely problem is incorrect setting for the auto neg, so causes 30% of Ethernet problems. Other likely problems would be port is not turned on, so on the electrical side. And then, of course, if you can't get traffic to generate, the screen might be red. Okay, and then possible layer 1 problems, of course, dirty fiber and connectors, bends and breaks. Check that wavelength used with the SFP is correct. So 1310 SFP needs to use the proper single mode fiber. And then for electrical, you can have new cable just use. You can use the visual fault locator as well. So a lot of issues can happen in the layer 1 side. And of course, we mentioned the auto negotiation. Extremely important to verify that. Okay. And then the flow control. So the flow control is something interesting. If flow control is enabled on your equipment, what it will do is if you go over 1 GE, it will start sending frames saying, calm down, you're overflowing. So that's really what the flow control is doing. On the HST 3000, you'll see that information on the LED. Okay. Okay, and then on the auto negotiation as well. So just wanted to ask if somebody could IM if everybody's hearing me. One person is saying they lost audio. Okay.
We can hear you just fine.
Okay, thank you. Okay, in terms of the far-end connectivity, let's look at the test far-end connectivity. The way that you would test your network is very simple. From one test set to another test set. But of course, today we have many other ways of testing your far end, including smart optics. Okay, so I'm going to talk about that a little bit. Now, how do you conduct a regular test? Very simple. Okay, the equipment will always allow you to loop up in an auto discovery fashion where it discovers the far end unit and starts sending traffic. So when you send a loop command, both sides verify the successful loop of the far end, and then at the end of the test, after running the traffic, you just remove the loop. So there's the concept of loop up and loop down in both cases. And of course, you can insert bit errors in order to find out if everything was fine. Okay. All right, so what I'm going to do is I'm going to go into my unit and show you guys. So as you can see, the test equipment, if I click on select test here, okay, in the newer firmware versions, and by the way, all of our firmware versions are always free, And release 18 is about to come out in November, so you should get that available on the website any day. And this is the quick launch menu, what we call the quick launch menu. What it allows you to do, as long as if you guys have used our test equipment before, even if you're not, we always have to load the application we want to test. So what that means is that, for example, let's say I want to test 10.100.1,000 copper side layer 2 traffic. So what I do is I select the 10.100.1,000 layer 2 traffic, and then I have three options: terminate, monitor, or loop back. Terminate means that you're generating the traffic. Monitor, you're receiving, and of course, loop back, you're putting into like a physical loop mode. Now, as you can see, it's grayed out, the terminate. That's because that's the current test that's loaded. Okay. So what you want to do is load the test and then start running it. Now, let's say, for example, you've run several tests in the past. They'll show up in your currently and recently used, and you can also say, you know what, I'm going to use that very often. So you can just say, click on the star here, and what it will do is it will actually add it onto the quick launch favorites here. Okay. So now, instead of going through the menu, you just click on it, and then you'll be able to, it will load that test for you. So in this case, I have, you know, an Ethernet layer 2 traffic test going on. The other thing you can also do is, in the dual port option, you can actually add two tests. So you can just go to add test and then add another test right there. Okay. Now, what we want to do is load the exact identical configuration on the far end unit as well. Now, in the setup, okay, in the Ethernet here, you'll notice here it says destination address 0 and then loop type broadcast. But you can also decide, I don't want to use the broadcast option, I want to put a particular MAC address. So you just put unicast here. You get your MAC address from the far end unit here, or it could be any other device under Ethernet. And then you select the source address of this equipment. So whatever this is, you can put it in there as unicast. So as an example, I could do, right, so I'll put 0, 0, 8, 0, 1, 6, 8A, 8D, and then F0. Okay, so now I'm actually forcing it to only go and loop up that particular device. Okay, and then I go back to results here. Okay, and then this guy in the destination should be the destination MAC address of this box. Sorry, source MAC address. Okay. And 6, 8A, 8D, and simply E2. Okay, so I'll go here, results, then here, results, and just say loop up. So you'll see here it says remote loop up successful, unit JDSU in LLB mode. And here on the action, you'll see that it says LLB is on because the local loopback is on. Now if I say loop down, you no longer have the test equipment saying that its LLB is on. Okay, so that's simply the way it's performing the loop test. So this guy is actually in mode of swapping MAC addresses. We'll do that again. Now this unit is ready to swap MAC addresses, and then I can, of course, before sending traffic, I go to setup, make sure I have the proper amount, otherwise I'll overflow the network. Okay, so I can say I'm going to just send, let's say 50 meg, for example. Go back to results, and then start traffic. Okay, so right away, here's an example. If you see that it's saying red, that means you're sending too much traffic. So let's go here. See, it's telling you lost frames. So the receive is 41, and I'm transmitting 50. So I've gone over the limit of the link. So let's stop the test, go to setup, and send less traffic here. So let's say we send 25 meg. And by the way, whenever you see alarms like this, simply by clicking the restart button, you'll be able to clear. One of the things is it will stay red until you acknowledge that you've seen the problem. So the reason being is that, let's say, for example, you're running a test and you leave, you're no longer in front of the test. You want to make sure that when you come back, if there was an issue, you want to see it. So it'll always remain red until you click on restart. Okay. So now that I'm sending 25, on layer 1, I'm getting back 25, layer 2, 24. And then you'll see the all summary okay. Now, summary SLA KPI is usually what I recommend to use. This allows you to see both, all three KPIs. So you'll be able to see throughput, frame loss, round trip delay, and jitter. So 4 KPIs that we're looking for here. And one side you can always put as summary status. So this is telling you if everything is okay. And of course, let's enlarge this. And then what you'll be able to see is the throughput, the frame loss, the round trip delay, and then of course the packet jitter information. Okay. Okay. So with that, I'm gonna give you guys a small break. After this, we'll come back and we'll continue on with the advanced testing and of course some of the the J-QuickCheck and other tests we have that allow you to save a lot of time and verify the auto negotiations portion as well. So Natalia, we'll give you guys a 15-minute break, so we'll come back at 2:15.
Hello, Tamina. I'm back.
Hello, Natalia?
Yes, I'm here.
Okay, perfect. Some people are saying they don't want the break.
Oh, okay. I cannot see any of the comments. I believe all of the comments have been sent just to you because I have changed your role to be a host.
Okay.
So I don't see any comments. You will have to make a decision.
Okay.
I cannot judge how many people have said one or the other thing.
Okay. So we'll start back at 2:15. So in 10 minutes or so. Just in 10 minutes or so, we're going to start back.
Okay, thank you.
Okay, thanks. So we're going to start up again. Natalia, are you there? Okay, so everybody can hear me? Okay, excellent. So we're going to start up again. Okay, and so if we were to summarize what we've covered so far, is essentially the the testing, the Ethernet standard, what layer 2 is all about, what layer 3 is all about, and how to make sure that you have connectivity in terms of the physical layer. What I'm going to do now is concentrate a little bit on the features and options, free options actually. I want to talk about this J-QuickCheck that we have in all of our equipment. This is an extremely good troubleshooting tool. Even before, oh, sorry, somebody's telling me I'm not sharing my slide deck. Hold on. Okay, so sorry about that. Okay, you should be able to see my slides. Now, I wanted to talk about JDSU's J-QuickCheck, which is a less than a minute test that allows you to troubleshoot, and even before running an RFC 2544 or a 1564 test, find out if you have connectivity. Basically, if this test fails, essentially the RFC 2544 will subsequently fail as well. Now, what this test verifies, firstly, is really the physical connectivity, and if you have the proper auto-negotiation set up. So whatever you're connected to from the test equipment, if it's a 100 full duplex, if the auto-negotiation is on or off, that's the first thing you'll verify. You'll see it like blinking red. So it's literally verifying your physical connectivity and also the auto-neg configuration. Now, the second test it will run is to find what type of loop you have out there. So the active loop is going to look for a JDSU active loop first, followed by, if it doesn't find another JDSU piece of equipment, okay, it will look for a hardware loop, which is just a physical connection, like a fiber, or if you have like a copper with the wires. And if it doesn't find a hardware loop, it's going to look for a permanent loop, which is a non-JDSU equipment that can intelligently swap MAC addresses and IP addresses. Now, the third test is really doing a basic load test with a single frame size and letting you know what the expected throughput may be. So really, a less than a minute test to verify all of these basic configurations is extremely good use of your time, and of course doesn't force you to waste your time by simply launching an RFC 2544 test. So this J-QuickCheck is available on all of the T-BERD products, not on the HST. So one of the questions was on the HST, but of course the HST will respond to all of the T-BERD, and you'll be able to run the J-QuickCheck to an HST. So once all of that is run, and then you see, for example, here in the slide it says expected throughput 10%. So that doesn't mean it's 10% successful. It means it's 10% of your standard Ethernet rate of 100 megs. As you know, standard Ethernet rate are 10, 100, 1,000. So 10% is just 10. 10% is 100 meg of a GIGI link. So once that's done, all you have to do is click on Run RFC 2544, and then it will launch into the RFC 2544 test. So let's talk about QoS a little bit. So we talked about layer 2 testing, layer 3 testing, how everything is connected and communicates. Now let's talk about a little bit of QoS. Now, why is QoS important for Ethernet testing? Simply because today we deploy voice and video over data networks. This was not the case before. It was all data. So quality of service is extremely important in order for your customers' experience to be positive, of course. So if you want to send, as you know, voice and video, very crucial. So you always want to prioritize that type of traffic. So quality of service, key performance indicators, very simple. Throughput, that's important to test. So bad throughput, what does it do? Cause improper rate limiting on the network, leads to clicks, pops, robotic sounds. So a lot of issues if you don't have good throughput. Latency, round trip delay. You'll see different naming convention depending on the standard. So you'll hear latency, but you'll also hear frame delay in the Y.1731 and then Y.1564 world. So what happens when you have latency on the voice? A lot of issues, overtalk, echo, drop calls, data, long download times. Okay, so latency is a big problem. Packet jitter, delay variation, so you'll hear about that. Poor latency caused by improper configs. Congestion, bad latency leads to drop calls. And of course, remember this, jitter doesn't cause huge effect on data, but it causes huge effect on voice or video. Now, frame loss, extremely important. So if you have frame loss, it affects every part. Okay. Now, finally, the new one you'll hear about is committed burst size. So oftentimes with bursty application, you might experience long time to load a web page, uploading, downloading a file. Video application, very slow, trying to download and view a video. So the committed burst size is actually tests the buffer in your configuration in your network. So oftentimes, if you've run the on our C2544 test in the past, there is a test called the back-to-back, which is a burst test, but it doesn't address the problems of today. It's a sustained burst test, whereas committed burst test will test one particular burst size, for example. Okay, you can configure it as you wish, depending on what the customer is expecting in terms of the bursting. Okay. So Ethernet testing in terms of throughput. All right. So what you want to do is generate the traffic, right, up to the full line rate, stress the test with a constant bursty ramp traffic, loop back far in, and then start the transmitting. And of course, if you have frame loss, then you have to reconfigure it to change the value of the throughput size. So the CIR, the committed information rate, will then have to change. So that's really how you test the throughput. Okay, you want to make sure that you have proper utilization of your link. Round trip delay. Okay, so what is the delay? That's the amount of time your frame spends in your network. So as you can see from test set to test sent, you see there's a timestamp that's assigned by the test equipment. So with the timestamp, that's how we can measure the round trip delay information. Now, if you ever want to test one-way delay information, it's extremely important that the time stamping is done properly, and why and how that the time synchronization becomes important. So both equipment have to be on the same identical time source. I would say GPS timing, which is available on the 6000. This allows you to do one-way delay measurements. Okay. Typically, though, if you have a symmetric network, one round-trip delay is very sufficient in order to find out the behavior of your network. So latency is the time it spends, your frame or packet spends in the network. Okay. Now jitter, this is extremely interesting. So jitter is defined by the variation in time of the frames and how long they've spent into the network. So for example, the variation in spacing. So what that means is that, let's say for example, one frame spend 5 milliseconds in a network, the next frame afterward spends 4 milliseconds, and the one afterwards spends 5. So the average over time will be 5 plus 4 plus 5 divided by 3. So the mean time and the average, that becomes your jitter information. So jitter is actually very bad for voice or video, not so much for data, but you don't want any jitter in your network when you're deploying voice or video. Okay, so that's QoS, KPI, that's extremely important. Now, bursty versus constant traffic applications, okay? Most of the applications today are bursty applications. So for example, HTTP, FTP, email, SharePoint, all the social networking, okay? Now, we've typically been able to test, the network layer, the data link layer, and the physical layer. But the gap has always been the transport layer, which is being used by all of these bursty applications that we're using on our mobile phones, on our internet, at home, and they're all using TCP. So we need to test TCP. Now, constant traffic uses UDP at the layer 4, and that type of testing is what you're doing when you're receiving a loop-up code and sending traffic. You're actually using UDP. Whereas if you're testing with a server-client relationship from one equipment to another, then you're actually using TCP. So UDP is frames that are sent not in order. TCP is, if you remember X25 days, you have to establish a connection prior to sending your traffic stream. So that connection procedure, what we call the three-way handshake procedure, actually is very important to test if that's being done properly. And of course, if we implement policing in our network, TCP is going to behave very badly. So I'm going to talk about that in a little bit. Now, bursty traffic and policing, okay? So what's important? This diagram actually illustrates bursty TCP-based application, okay? So if the burst exceeds the CBS value during the police or time interval, then the excess bytes packets are dropped. So that's extremely important to verify, and that's what we verify in the CBS testing. Now, the CBS testing is available in both our RFC 2544 suite and also the 1564 suite. So instead, you do have two options in the RFC 2544. You can either choose to run a regular back-to-back test from the RFC standard, or you can run our CBS test, which is actually verifying real TCP-based applications. And in the 1564, of course, you have the CBS test. So really, the decision which standard to use for which test, okay? So I want to start off with the J-QuickCheck. Of course, that's for the basic connectivity, auto-negotiation, and throughput. So J-QuickCheck is not a feature that you pay for. It's there by default for all of our T-BERD equipment, okay? So you always have the J-QuickCheck to use. Now, RFC 2544 is the industry standard. It's been around since 1999, and the RFC 2544 has been initially created to stress test your network equipment. But over the years, most of the carrier service provider have used it to turn up their circuit and certify a circuit. So of course, it's perfectly good for single stream, latency, loss, jitter, throughput, and of course the CBS testing. Okay, but again, the emphasis to remember, well, the key point to remember here is for single stream. Now, Y.1564 came about not so long ago. What that does for you is, of course, multi-streams testing. Now, let's say you don't want to run RFC 2544 multiple times with multiple VLAN IDs and multiple priority. What you would select is Y.1564, which allows you to do multiple streams, latency, loss, jitter, CIR, EIR, CBS, and EBS. Now, Y.1564, of course, behaves a little bit differently in terms of the testing in comparison to RFC 2544. Now, RFC 2544 takes care of all the frame sizes. Now, 1564 doesn't necessarily address testing all of the frame sizes in every stream. So what we've done, of course, is we've allowed you to do the configuration test of the CIR with multiple frame sizes, which we feel is extremely important. So you can run multiple frame sizes per stream with the 1564 test implementation in the T-BERDs. Now, finally, RFC 6349, the Layer 4 TCP QoS, what does it verify for you? So TCP window size, buffer size, and of course, policing versus shaping. Now, policing is simply when you decide to just drop traffic when it goes over a certain amount. Shaping is when you decide to enqueue traffic until there's space available in your network to actually send over that traffic. So shaping, of course, is much better on bursty applications and applications that use TCP to connect. Policing, if you drop TCP frames when you're policing, it will cause a lot of retransmissions, which will cause the slowdown of the download. Okay? So we'll talk about that in a little bit. Now, what we've done is we've put together Ethernet testing, so you can run automated fashion something that we've called TrueSAM. This allows you to do Y.1564 or 2544, one or the other, for your layer 2, layer 3 testing, and followed by the RFC 6349 all in one test. So really it becomes like a one-button push to be able to run both tests and turn up your circuit. Now what we recommend is not just to use RFC 6349 when you see that there's a problem, but if you test your network for the buffer size and the implementation of the policing and shaping right off the bat from the beginning, you'll be able to clear yourself of guilt. So you'll have proof, like a birth certificate saying, well, I've run this test, the window sizing was fine, customer, it's on your side. Or carrier, it's on your side. So it really avoids the finger pointing. Okay. One of the things that we've also done to save a lot of time for the RFC 2544 test is that we run concurrently the throughput, the delay, and the jitter. So this saves you around 40% of the time. Instead of waiting for throughput and to end, then followed by delay, then followed by jitter, all three of those tests are run simultaneously as long as they're configured at the same duration, and then followed by the frame loss test. So this is a huge time saver. And of course, RFC 2544 used to be like a very long test, because what they expect is for you to run this test, since the original intention was to run the test to stress your network equipment, it can run for a very long time. But of course, everything is user configurable. And as you can see in this slide, you'll see throughput, latency, jitter, frame loss is selected, not back to back. And then 3 frame sizes are selected. So you have 64, 512, and 1518. Okay? So that's one of the ways, to save some time. So in order to run an RFC 2544 test, it's very simple. So I'm going to go into my equipment. Okay. So let me stop the traffic here. Issue a loop down code. Okay. Now, of course, you can run a regular throughput test and save the test results in our test equipment anytime. So, for example, I just ran a test. If I wanted to, I could still generate a report. So it's very flexible. You could say, I want to create a report. Okay. And then it actually lets you choose the contents of the reporting. And when you click on choose contents here, so for example, let's say you want the configuration group, or let's say you don't want that, or you just want the results. So you go to the results and you select, okay, I just want to see the latency graphs. So it's extremely flexible in terms of what you want to configure in the content of the report. And then of course you can say select screenshots if you took screenshots. So screenshots are very important. We allow you to do screenshots at any time. So for example, you're running a test, you see something weird. Under tools, you'll have take screenshot. So it will just take a screen capture of this particular window. You can use that anytime on your reporting. So of course, if you want to run a regular test directly from the equipment without launching an RFC, that's available as well. Now let's go to Enhance RFC 2544. Okay. So as you can see, if you guys are familiar with our older GUI, it's a tabular format. What we've done with Release 18 is that we've allowed you to do more of a guided format. So what this allows you to do is it will ask you questions. It will say, what do you want to do? What do you want to load? And of course, if you have existing RFC 2544 tests loaded, then you can definitely use those. So it will tell you edit previous configuration, load configuration profile, or start a new configuration. So let's go to start a new configuration. And you'll always see the little camera on top in order to take screen captures. And you can also go to, so let's say, for example, you've configured the test controls, but you forgot something on the network side. You can always toggle back and forth between And let's say, for example, you want to load a config and you want to go directly to run tests or directly to the J-QuickCheck. That can be also done under the go-to. So let's go here, start new. Okay. The first thing it's going to ask you is, do you want to run a symmetric, asymmetric, unidirectional test, loopback, or downstream and upstream? So typically, RFC 2544 is going to be symmetric. Now remember, if you want to do asymmetric, which means you can have one side, like typical DSL network, it could be one side is 50 meg, the other side is 70 meg. You would definitely need another JDSU equipment because of all the in-band communication that we need to do. So just remember that if you want to do asymmetric, 2 JDSU equipment. Symmetric loopback, we're going to select that. Okay. Now, it's going to ask you, do you want to encapsulate and the traffic type, okay? So set loop type, MAC address, all that information if you need to. So for example, if I go to set loop type and MAC address, okay, so you have the destination MAC, you have the default MAC. This is all preloaded from whatever I configured earlier in the main page, okay? Then it will say, do you want to use a configuration template? So that means there's existing templates you could use. Okay, I'll say no. And then it asks you which tests you want to run. So throughput, latency, frame loss, back-to-back, these are part of the RFC standard. And then we have additional tests. So for example, do you want to do packet jitter, burst test, extended load, loopback only? So we have several options here. Sorry. And then, of course, you decide if you want to do what type of measurements. So typically, it's layer 1 megabits per second, and of course, how much. So as we know, this particular link doesn't allow you to go over 40. So we'll send 25 meg. So this is extremely important, the max bandwidth. RFC 2544, its job is to discover the bandwidth configured in your network. So when it does that, it uses a binary algorithm. What happens here is that it will start off at a gig, half it to 500, half it to 250, half it to 125 until it gets to that 40 meg. So that could take quite a while, but if you already know the max bandwidth configured on your network, it's better to just configure it right here. And of course, you have advanced utilization settings if you like, allow true 100% traffic or not, and then you can go back as well. Okay, so we'll select 25. Okay, and this is where you decide which frame sizes you want to run. So what we're going to do is we're going to run a fast test of a small frame and a large frame. Okay. And of course, you have the option to do jumbo up to 10,000. So you have the RFC 2544 JDSU enhanced. In the question mark, it explains, so there's 2 methods, okay? So the maximum throughput, choose the standard RFC. Okay, the JDU enhanced method uses the measured layer 2 average percentage utilization. Okay, and then of course you can choose the measurement accuracies, and then if you go to throughput latency measurement settings, you know how much percentage of the latency bandwidth is acceptable. Let's go to next. Okay, and of course the standard way, which is the ramp test, granularity, advanced frame loss measurements. Okay, and how long do you want each test to run? So number of trials 1, duration 30 seconds. That means all of them will run simultaneously. Okay, and then here it asks you throughput frame loss tolerance. Okay, typically it's 0. The latency. Okay, if you want to do the show pass fail, we want to enable these because we want to see which test failed if one does fail. Okay. So the latency here by default is set to 1,000 microsecond, 1 millisecond. So typically, I believe in this network is around 54 milliseconds. So we're going to put 55,000. Okay, and then jitter, we'll put 4 milliseconds. Okay, this is so that you don't have a failed test based on the latency present in the network. Now I'm going to save this to my profile. Okay, Okay, so it's been saved. Of course, you could have changed it to any other name, but it will always save it by the date, so the 4th of November 2013. Next, and then we go to next, and then you'll have the J-QuickCheck. So again, it will say press start to run at line rate, measure throughput, and if you didn't want the line rate, so in this case, okay, you use test using configured RFC max bandwidth. So I configured 25 meg. That's what I wanted to run at, not at the line rate. Okay. So remember that in the J-QuickCheck, very important to indicate whether you want to run line rate or not. So it's going to be the local port, find out if auto negotiation is okay, find out if the active loop is available, and then you start the test, a basic throughput test. Okay, so it's running the throughput test at 256 kbytes. Okay, and then once that's done, we're going to be able to run an RFC 2544 test. Okay, so it's telling you 25, it's just fine, and then we say next, and then we just say run test. So extremely graphical, visual, and you'll get all of these graphical reporting on a PDF file generated later. So if we wanted to go see, so as you can see, throughput, latency, jitter running simultaneously, which is beautiful. You don't have to wait for one to finish versus the other. If I wanted to go check out the test results, I just click on this. Okay, and then you'll be able to see the results live, what's happening. So it's running 64 and 1518 at the same time. And then it will give you the measured layer 1, layer 2 measurements. So if I go back, I can also go to the latency. Okay, so this test will run for approximately 4 minutes or so. Okay, so very easy. Throughput, latency, packet jitter, frame loss separately. And then, of course, it's telling you the active loop and graphically showing you whether it's pass or fail. You can always use this little camera to take a screen capture. So, for example, if you saw something strange there, and this could be included into the PDF document later on. Okay. So now that was for the RFC 2544 test on release 18. Okay, so that, remember guys, that firmware version is release 18 for whether you have a 6000 or an 8000. Okay. Okay, so if I was to summarize, the RFC 2544 test consists of 4 tests: throughput, frame loss, jitter, round-trip delay. Now, jitter was added later on by most of the test equipment vendor. Certainly, we've included it simply because we do deploy voice and video over data networks today. So this is an old GUI view of what the RFC 2544 may have looked like, and you might see this. A lot of people might have this. So this is a typical PDF document. I want to show you guys a little bit overview of the product line. Okay. Okay. Sorry, guys. All right, so let's start off with the HST 3000. If you guys have used this in the past, this, of course, is an extremely popular device, but not only for Ethernet testing, but also for triple play service turn-up. So, for example, the copper testing, the VDSL testing, it's an extremely powerful box. Okay, so of course, this one is not the touch screen. It's essentially menu-driven, but again, the same concept. You still have to load an application and then start running the tests, and you'll see, all summary okay. So that concept always exists. So dual electrical port on the side, and then dual SFP slots on the top. That's essentially what your HST 3000 will look like. Okay, and then of course, in terms of navigation, what you're seeing here, we also have a lot of job aids available that allow you to test with the T-BERD, with the HST 3000 on RFC 2544 test, for example. So we have nice job aids that we can provide as well with screen captures and going step by step on how to configure that. So again, this is just showing you an overview of where to click in terms of the configs. So simply put, an HST 3000 can be tested, across your switch, and then you have. This is just going to go over if you have an HST 3000 with you, we could run this test. So it's very simple. If you do have one, you would need to select the terminate option, just like in the T-BERD 6000 layer 2 traffic option, and then go into the testing. So again, the same exact procedure as a 6000. You would want to do like a discovery loop, and if you have a far end unit that's JDSU, it will automatically discover it. If you're doing layer 3 testing, though, you want that ARP done shown on the top to make sure that the IP address settings are okay. So again, very simple. You go into the action, loop, start loop, and then start traffic, okay, under the summary results. Okay. Now, if you want to run an RFC 2544 test on an HST, the configurations are fairly simple. Under the configure button on the top, you'll see here loop type, for example, RFC 2544 mode, auto negotiation, source type, transmit payload, and all that. So by clicking the side arrow soft key, you'll be able to go in between summary settings, network visibility, summary results. So all of those just have to use the right arrow. Okay. So let's look over at the product portfolio in terms of Ethernet testing. So of course, we have a smart class, which is just a loop device, a simple loop device if you want one at the far end. We have the HST 3000, which does DS1 to GIGI, the T-BERD 50 at 100, which does DS1 to 10 GIGI, and then the 6000 that does dual 10 gig, so all the way from DS1 to dual 10 gig, and the T-BERD 8000, which supports 4000 gig, so all the way from DS1 to 4800 gig on the same unit. Now, if you have needs, particular needs, for example, for OTN, that's available on our 6000 and 8000. If you have particular needs for 6349 testing, that's available on all the T-BERDs, so 5800, 6000, and 8000. So this is kind of a summary of which products support which feature set, but more or less all the T-BERDs support all the same features. Okay. Now, the smart class Ethernet, if you've ever seen it, it's really there to be acting as a loop device. Really nothing fancy to configure other than to set it up as layer 2 or layer 3. That's it. Okay, and everything else would be configured from the near-end unit. Okay, so, all right, okay. Now, let's look at the T-BERD 5800 architecture. This one is a very small box, but extremely powerful because you are able to do all the way DS1 to 10 gig in the same box. And of course, if you look at the GUI, same exact GUI as the 6000 I've been using thus far. Now, the P5000i we talked about earlier, that can be plugged into a 5800. And of course, we have fiber testing as well, so a USB-based power meter. That can be plugged into a 5800 as well. So SONET, fiber channel, 10 gigi, no module swap, all in one box. And then, of course, you have an external bits clock input as well in terms of time sync. On the side panel, you'll see 2 USB. So there's several ways to extract the test results from our test equipment. One of them being, of course, via USB. The other one being via FTP if you remotely log into it. And third is Bluetooth Wi-Fi option, so which is really brilliant. If you enable the Bluetooth option, you'll be able to synchronize to your phone and get the results off of the test equipment via Bluetooth and then email it from your smartphone. So that's one of the things that's pretty neat. So of course, the 5800 has several flavors. You can have it very basic, just 2 ports, but you can also have it full-blown with all of the ports available. So it really depends on your needs. Again, this is a box that's a non-modular box, so whatever ports you decide to have, that's what you have. This is the system GUI overview of 5800. So for example, if you want to do all the housekeeping stuff, that would show up under the system, and the test is where you would run the actual tests. And as you can see, you have the Bluetooth option, the remote VNC. So typically, if you want to remote log into any of our units, you can use the application called VNC. But in case VNC is not allowed or not permitted, or you don't want to download it, you can also use Internet Explorer just simply by using port number 5800. So port number 5800 is the one used for VNC access. Okay. Now, let's say we go to the test GUI. Again, same exact setup as our 6000 that we were looking at earlier. We've put in a new tool called Ping, which is nice. So before you had to load that application, but today in the newest release, the Ping option is right in the front page. So the first thing you want to do in the Layer 3 world is, of course, run a Ping test to make sure that you have connectivity from one end to the other end. So the Ping test is extremely useful. All right. Now, let's look at our 6000A. This little box is a modular box. Now, a lot of people don't know this, but the intelligence of this box lies in this module right here, the MSAM, the Multi-Services Application Module. And of course, then you see on the bottom there, those are the PIMs, the Pluggable Interface Modules. The mainframe here, that's really used essentially for configuration purposes, but of course, all of the intelligence is in that MSAM. That MSAM can also be plugged into a T-BERD 8000 as well. It's the same exact module that goes into there. Again, the P5000i, that can be used on the 6000, USB ports, and then this one can actually have two 10 gig ports running simultaneously. We also have a new PIM for the SFP+. What that means is you can put both GIGI and 10 GIGI into the same PIM. Okay? And then finally, of course, for advanced fiber optics testing, that's also available on the 6000. This is the GUI view of the main page of a 6000, and as you can see here at the bottom, it says BERT, and then it's yellow. So whenever you want to enable, disable the BERT, you just simply click on that and make sure that it's no longer yellow or highlighted, it turns gray. Now, you also see the microscope right there. So as soon as you plug in a microscope, that's also available. So that's how you toggle between testing. Okay. If we look at the GUI overview, again, pretty much the same exact as the 5800. Again, you see here remote loop up successful. You have the ping, traffic started, and the test always flashes to you what it wants you to do next. So under the action, you always see the loop up flashing or the traffic started flashing because it wants you to do that test next. Now let's look at the 8000 architecture, and that's also a modular box. It's basically slices. So the first portion that you see here, which is the mainframe, again, the mainframe is only used to navigate and configure. The back portion is just the battery pack. So again, the intelligence lies in the modules. So for example, the 100 gig transport module, MSAM, the OSA, the OTDR, you can literally stack them up very easily one after the other. So for example, this particular setup allows you to do all the way, from like DS1 to 100 gig on the same exact mainframe. So the 8000 is a very popular device in COs where you can run multiple tests from there, and of course, 100 gig and 40 gig QSFP plus optics. So we're one of the ones that we put both QSFP plus and 100 gig on the same module. This allows you to not have to swap out the optics. So a lot of people didn't know this, I found out, but there's a certain amount of insertions that you can do with the optics, especially for CFP 100 gig optics. There's a finite number of times that you can remove and then insert that. So one of the good things is that since you have the QSFP Plus and the CFP, you don't have to remove or insert that many times. So of course, we also recommend, there is also finite number of time for XFPs and SFPs, but not as delicate as a CFP, for example. Again, we have a lot of job aids available for all of the testers, the 5800, the 8000s, navigating through the GUI, and then setting up, for example, an RFC 2544 test. Okay. So what we're saying here in this section is how to use the select test menu. So let's go back to my equipment here. Okay. So we've completed the RFC 2544 test. So before I go back and navigate through the GUI, let's go and generate this test report. So again, you can put the customer name, technician ID, test location. You can put your customer logo or your logo, and then create the report. So in the create report, you have several options, either a PDF, a CSV, a text, or an HTML file. And then you just say create report. And what it will do is that it's going to generate a PDF file directly with all of the reporting on there. So let's go to this equipment. And what I want to show you guys is how to select the different tests. Okay. Okay. So if we go here under select tests, okay, what you'll see is Sonnet, SDH, Ethernet, fiber channel, OTN, and then benchmark. So here, if I go here, Ethernet, okay, let's say I wanted to do optical testing. I'll go to 1 GigE optical. And then I can choose either layer 2 traffic or layer 3 traffic or layer 4 TCP wire speed option. Now, layer 2 multi-streams option can also be selected, and we can do up to 10 streams simultaneously. So this is the option you want to select before running an before running a Y.1731 test, because Y.1731 allows you to do multiple streams testing in the same time. Of course, you can still run Y.1564 in a single stream, but really its main purpose is to allow you to turn up multiple streams in one shot. So if I go to terminate layer 2 multi-streams, okay. So while that's loading, I just want to show you guys what your report would look like on PDF side. So enhance RFC 2544 test, extremely graphical. You'll see throughput, latency, packet jitter, frame loss, and then all of the values, all of the configs, and then, of course, the graphical results of each frame size. And then we always give you layer 1, 2, 3, and 4 results. Okay. So let's look here. Okay. As you can see, the rate, the measured line rate, the measured frames per second, and then, of course, the latency, 54. Okay. So that's essentially what your PDF file would look like. Okay, so let's exit this. All right, so when I switched over to the GigE, you'll notice it says the testset has detected a possible error because GigE layer 2 stream. So it's telling me you select an optical test SFP, looks like it's an electrical SFP. So it's telling me that I've put in the wrong. So if I go here to SFP2, let's say, for example. Okay, so let's go to setup. Okay, so you see here on the SFP1, it says Ethernet 100 base T. And by the way, that's hot swappable. So let's look at SFP2. SFP2 doesn't have any inserted SFP. So one of the nice things is, let's say, for example, you have a lot of SFPs laying around. You can always plug them into one of our test equipment to find out what they actually do. So it will load all of, the vendor name, the digital diagnostics information, of course, if it's a 1310, 1555, whatever rate it may be. Okay, so we're going to go back to the copper mode. Okay, so I'm going to simply use one of my shortcuts. Okay, we're going to exit out of this RFC test. I just wanted to show you guys a summary of what your test results would look like in terms of layer 2, layer 3. Of course, you have the capture decode option, RFC 2544, 1564, and then, of course, the 6349 test. So the 6349 test looks a little bit prettier now. Let me show you. Okay. And then one of the other things to remember is, in terms of results, there's several possibilities. You can definitely do graphical output of the results as well. So let's say I exit this out. Okay, we'll go back to our test equipment. Here you have summary, and then you also have the graphs. So if we go to graphs here, this actually allows to see, visualize, and we can also plot all the data into CSV files right here. So if you just click on the Save button here, this will save all of the plot points as well. Okay, so extremely flexible in terms of what you can visualize. If we go to Ethernet, this will give you, of course, the auto-neg status, but you can also get layer 2 link counts. If you want to see particular counts, how much received, how much transmitted, if you want to see the BERT stats, okay, and the boxes all have the option to have capture decode option. If we go to capture here, it allows you to enable. You just enable the capture, okay? Then you say start capture, and then save the capture buffer. And Wireshark is actually built into the equipment, okay? So what that means is that you can, create a PCAP file, generate the Wireshark on board the unit, and then simply analyze the data directly on board your 5800, 6,000, or 8,000. Okay. Okay. So finally, in terms of the carrier Ethernet bundle option, we have an option called the J-Proof, which I'll explain in a bit, the layer 4 traffic option, the capture decode, J-Mentor, and J-Profiler. Now, J-Proof is an extremely good test to use in a layer 2 environment. What it does is it verifies that all of the layer 2 control protocols, for example, CDP, STP, pass through seamlessly across your network. So that's a nice test to have. The capture decode, of course, is the capturing and the Wireshark option. Now, J-Mentor, J-Profiler, very neat tests as well. What it does is instead of you sitting down and going through the PCAP file to look for the issues, the J-Mentor will do that for you. So what it will do is it will analyze the PCAP file and will let you know the health of your layer 2, layer 3, and layer 4 environments. So for example, if you had a lot of retransmissions, it will tell you that graphically, and it will tell you which source IP may have caused that issue as well. Okay. So that's essentially a summary of the carrier Ethernet bundle that's available on the T-BERDs. Now, when massively deployed test equipment, when you do massively deploy test equipment, it's very nice to know where these equipment are and how to get a centralized location to store all the test results. So one of the things that we came up with this year is called StrataSync, which is really a cloud-based system that allows you to not only do asset management, so to keep track of all of the parts, all of the equipment out there via the cloud, but also allows you to push firmware updates to the equipment automatically. Okay, so let's say, for example, there's a new firmware available, like I was mentioning, release 18 on the 6,000 and 8,000. It would, as soon as your test equipment would go onto the cloud, so just on the internet via Wi-Fi or via cable, it would be prompted to say, would you like to upgrade your unit? We have a new firmware available. So that's automatically done. So asset management, update deployment, and then test data management, which is the most important, file storage, printing, exporting. So it's extremely important to store those results and have somebody be able to access those at any moment. So as an admin, or as you can have hierarchical, authentication on the StrataSync server. That means is, for example, a manager could log in, go check out the test results, email them out, and also you can push the configuration on the equipment. So let's say, for example, you want all the 6,000s to have a particular RFC 2544 configuration for turning up a 10 gig circuit. So that can be easily pushed from StrataSync. Okay, so StrataSync is an extremely powerful tool that we support, you know, on the HSG 6000, 6000, and also the optical units as well. So finally, let's talk a little bit about the fiber inspection again. That, of course, is available in all of our equipment, and I'm not going to elaborate too much on that, but let's talk about the smart probes. Now, everybody loves the concept of being able to issue a lookup code and then controlling everything from your near-end unit. So what we've come up with, and I can tell you it's been years in development, is a smart SFP called the JMEP that allows you to do loop back directly to the SFP. So if you could, basically you could plug it into any of your network equipment just like you would a regular SFP, okay? And this SFP is smart, so what it will do is it will be able to loop up, so swap MAC addresses and swap IP addresses intelligently, send traffic back to your originating unit. So that originating unit can be any of the T-BERDs, the HST, and the QT600. So the QT600 is like a pizza box probe that allows you to do multiple RFC 2544 and 1564 tests. So I believe up to, on the 10 gig unit, up to 32 simultaneous RFC 2544 tests, okay? So this smart SFP is the latest technology that we've developed, and it's become extremely popular, and everybody is very much looking into deploying that solution today. So that's something to look out for in the future. Okay. So Natalia, are you there?
Yeah, I'm here. Hi.
So maybe we should open up the lines for some questions now and see what else we could share as well. Because I see a lot of questions coming up in my chat window, and I'd love to respond to them.
So it's unfortunate I only have one single question. All the other questions must have been sent just to you.
Oh,
so they're not visible to me. You will have to read them.
Okay.
The one I have to do, which I can read is there an OTDR T-BERD 6000 class? And
we can definitely set one up in a subsequent time, of course. We don't have one planned right now that I know of, but we can definitely organize that.
That's the only question I have. All the other questions were just to you. And one more, which was really regards the time that we have today's webinar. This time doesn't work for Asia-Pac customers. We understand that. We did have a series that was held in September and October that happened at 9 a.m. Eastern Standard Time. That was a bit better for the Asia-Pac customers than this time. But one comment I would like to make is that if you register, even if you are not able to attend the session because of the timing, we do send a follow-up that includes the presentation and the recording, and you can then view it at your leisure.
Yeah. So a lot of people ask if we can have the slide deck, and definitely we'll provide you the slide deck for your review. And this whole session is being recorded. We'll be providing you a link to that as well. Okay, so for any subsequent times you'd like to review. Okay,
so that's all I can see. Unfortunately, you will have to go through other questions and read them and respond to them. I'm sorry.
Okay, so let me answer to one of them here. Okay, so the recording, of course, we're going to give you that. Okay, so somebody from Brazil asked about if they can be paired. Yeah, so all of the equipment interoperate with each other. So as an example, I actually have this in this slide here. You can pretty much have anybody work. Any T-BERD, any HST, they all work with each other. And of course, you can have loop-back testing and head-to-head testing. Head-to-head testing meaning you're sending traffic in one direction, received on that one end, and then that one end is also sending traffic received on the far end. No loop. So yeah, all of them can be paired, of course. So let's see, what else? Okay, I think we've answered pretty much. All right, somebody was asking updates are for free for the T-BERD 1500. So Natalia, perhaps when we do send out the slide deck, we can also provide a link to the firmware upgrade page for the T-BERDs.
Yes, we will do that.
Okay, so we'll do that. Some people had questions about HST 1000, so we're going to provide you the link for the firmware upgrade on the HST as well. And of course, it depends on how old the modules are on your HST. Okay, so let me see. I don't see any other questions right now. Okay. Okay, so hopefully that answered the questions. If you do have questions, please. Oh, there you go. I have a question here. Okay, so when testing electrical Ethernet, can you test both Ethernet ports on the 6000? Absolutely. So with the dual port option on the 6000A, both ports can be run simultaneously. So it's actually mimicking two different test equipment. Okay, so you can definitely run both together. Okay, so let me show you guys what the port looks like. I believe I had a slide earlier. The visual. Okay, so here we go. Okay, so you can see there, that's just an OTDR module that's plugged in there, but when you have the MSAM module in there, you can run two at the same time. So not so for the HST. The HST can run one test at a time. Okay, so you have on the side, you'll have like two copper ports, and on the top you have two SFP ports. It's one port at a time. But you can have multi-streams, so you can have, I believe, up to 4 streams, though, simultaneously running. Okay. Any other questions, guys? Gals. Okay, so there you go. Okay, so the question again, sorry. For the smart class, yeah, you could generate traffic from one end as well. It doesn't have to be configured only to be as a loop device. You could, you have several options on the smart class. So one of them could be that it also generates RFC 2544 traffic. But you won't get the advanced features that you get on the other devices. Okay? So simple RFC 2544 generation. No 1564. Okay, so any other questions, guys? Gals? Okay, there you go. So the other question I have is, it's enough to run only defaults when running RFC 2544 only on a data Ethernet circuit. So when you do run only the defaults, it's actually a longer test. So the RFC 2544 default settings will ask you to run all of the frame sizes 60 seconds each, and the latency, 20 iterations of the latency test each, and then the jitter test at 120 seconds. So this will actually be even more thorough test, I guess you can say. Okay, so somebody's asking for the help desk number for the 1500. It's the same number as the TAC. So at the beginning, let me show you. So here you can see the TAC information, 1-855-275-5378. Okay, so you just simply dial that number, which is Ask JDSU, 1-855-Ask JDSU, and then you select 311. So the first option is going to be 3, then 1, and then you'll get directly to the 1500. So somebody's asking me, can we use the fiber scope to view live fiber? I believe that's not a problem because the scope is just a microscope. You can have the laser on, but I wouldn't be 100% sure on that answer. So, William, I'll get back to you on that. Okay, so the dB level question. Somebody's asking, what is the right dB level? This will be indicated on your SFP. So one of the nice things about our equipment is that when you insert an SFP onto the unit and the interface under SFP connector, you'll see exactly the dB level acceptance. So in this case, of course, you see it says min-max rate, power level. In optics, like a 1310, it will tell you what is the proper dB level tolerance. Okay? Yeah, so there you go. Somebody offered the proper answer. So you don't want to damage your vision. I like that. So there you go, fiber, unless it's heavily padded. So it's better to have it not lit when you're doing a scope test, okay? But yeah, essentially, if you want to see the right proper dB level, all you do is you insert the optics into the test equipment, and then it will tell you the max values. All right, let's see if there's any other. Okay. So this is scheduled for till 4. So I do want to show you guys a little bit overview of the 1564 test, which I haven't gone over, and so we'll continue with that. Oh, URL. Okay, so we're going to provide the URL for the upgrades via email. Okay, so Jason, what I'm going to do is I'm going to just wrap up here with the SLA testing with the Y.1564 test, because it is something that's becoming extremely popular, especially for multi-streams testing. And it's something that, of course, we recommend if you have multi-streams as opposed to testing with RFC 2544. So Y.1564 hasn't been around for that long, and that particular standard was ratified by the ITU in Europe. Now, two main things to remember when testing Y.1564 is that it's two-phase methodology. The first phase being a configuration test. What you have to do is verify stream by stream if they have the proper throughput. Second phase of that test is to run all of the streams simultaneously and find out if they meet the KPIs, so the key performance indicator, which are delay, jitter, and frame loss. In naming convention, in the Y.1564 world, it would be frame delay, frame delay variation, and then frame loss rate. So you'll see that in the test equipment. Okay. All right. Now, this option is actually available on the HST 3000 today. So you could definitely run this multi-streams test, Y.1564 test on the HST 3000. Okay. In the 6000, this is what it looks like. So it's again the guided formula, just like the RFC 2544. The J-QuickCheck is also included all the time to verify the physical connectivity and the loop type. And then you run the service configuration first, then the service performance test, and then you get your results. Okay? So main thing to remember is on the Y.1564, I'm going to show you guys this directly on my equipment. So the first thing to remember when you're running Y.1564 is to make sure you select the multi-streams option. So here you see you have Ethernet layer 2, layer 3 streams option. Okay, so what we're going to do is we go to Ethernet, 10.1000, layer 2 multi-streams, and then terminate. Okay, I have a funny question. Yeah, no, it would not damage the scope. The scope is just a camera. Okay, so somebody was asking me, yeah, it might damage your eyeball if you have a lit fiber, but definitely it will not damage a microscope because it's just a camera. Good question there. So what I'm going to do is set this one up to layer 2 multi-streams. Now let's go to the other one and set that one up as multi-streams as well. So let's go to Ethernet, 10.1000, layer 2 multi-streams, terminate. Okay, so we're going to acknowledge that we've seen the alarm, click on restart, and you'll notice here the action is flashing. It's telling you, oh, well, you should start traffic. So what you want to do is mainly go into the SAM complete. Again, it's going to be guided. It's going to just ask you questions, and it will tell you simply answer what would you like to test. All right, so now it's going to ask you whether you want to configure the test settings manually or load the configuration from a profile. Now, load the configuration from a profile is that you've already set it up, and then you know exactly what was set up in it, and then you just simply load it and you start going to the run test. So now in the configure test settings manually, that's what we're going to go through. Same thing as in the RFC. It's going to ask you whether you want to do a symmetric test, asymmetric, unidirectional, loop back, or downstream and upstream that are different. So we say symmetric and loop back. This is for the frame settings. So let's go look at the MAC address settings. It's telling you factory default, and that's fine. For the source MAC, let's go to next. Okay. And then in terms of number of services, we allow you to go up to 10 services simultaneously. What I'm going to do here is I'm going to do 2 different tests here. Okay. So what we'll do is, by the way, you can name them as you like. So we'll just leave it at service 1 or service 2. But in the configure triple play option, that's where you decide what you want to do in terms of types. So if you leave it at data, you can choose whatever frame size you want and whatever CIR value you want to assign to it. If you choose, for example, voice, it actually does industry standard codes that it loads. So for example, let's say I wanted to do an H261 mimicking it. If you select that, it will load for you the frame size, which is typically 138 bytes, and then you have the CIR value of 0.13. Okay? And then, of course, you can do multiple calls, which will increase the CIR. Let's say I wanted to do 50 calls, right? Just go here, and then look, my CIR is 632. Okay? So that's one option. You can either load it like that. I can call it voice as well if I like. And then here, the second one, I could call it data, and then just leave it as is. Now, if you look at the destination MAC and frame size settings, let's go look at that. Okay. What I was mentioning earlier is that 1564 didn't necessarily consider, the concept of testing all of the frame sizes as in RFC 2544. Let's go here. We put in something called emix. Well, emix is nice. What it allows you to do is an iteration of the multiple different frame sizes. So you have 64, 128, all of these frame sizes done cyclically per stream on the configuration test. And in the performance test, it will select one and do that test simultaneously. So this is a nice tool to have because it allows you to still verify that these frame sizes are passing through. Okay. All right. So let's go back. Okay. And of course, the destination MAC information. Let's go get my MAC information from here. So guys, the reason I'm actually getting the MAC information is not because I don't want to do the auto discovery is that there's several T-BERDs in that network. So I may loop back a different equipment that I don't want to loop back. So we're going to set up the MAC address manually. Okay, so so 00, 80, 16, 8A, 8D, and then F0. Okay, so if I select it there, it's going to just set it up for all of them. But of course, you can have different MAC addresses for each stream if you like. Okay. Let's go to next. So now it's going to ask you, do your services have different VLAN IDs or user priorities? So we're going to not encapsulate for now. Just leave it as is. But of course, you could put like the same VLAN ID for each of them. You can do Q and Q, or you can do one VLAN per stream. Okay, so notice the data is 0. So that one I have to manually put it. So remember, this network allows only 40 meg of data. So I'm going to just put like 20, for example, here. And then here, the option for policing is enabled. So what this does is select policing, okay. So this will actually shoot 7.9 as opposed to 6.32 as opposed to 20, and then in this case 25, just to verify that the polices are working properly, okay. Now, a failed test is actually when you are able to overrun your circuit, okay. Max load, by the way, is calculated this way, but you really don't need to remember that, okay. So I'm going to disable this little policing guy. Okay. Now it's going to ask you, would you like to perform the burst test? And you can say yes or no. I'm just going to show you what it looks like. So if you were to do committed burst size or CBS policing based on the MEF34, you have the choice between the two. And then all you do is you simply put the value in K bytes. Okay. And then of course there's advanced settings as well for the burst testing. Tolerance, ignore plot frames. Okay. So if I go here in the voice, okay, it allows you to do 0 to 1,000 in terms of burst. Okay. Now this is extremely important. So if we leave these values at 0, chances are you're going to have a failed test. Now the frame delay, which is the round trip delay, we know it's 54 milliseconds around. So what we're going to do is we're going to put it at 60 to make sure that it doesn't fail. Okay, and variation, I'll put it at 4 milliseconds. Sorry, the jitter. Okay, so what we're going to do is we're going to do an extremely short test. 5 seconds, 3 steps, and then let's do a minute. Go next. We'll save the profile. So I'm going to save this profile so that next time I don't have to go through all the steps. Next, and then here, this is where you decide whether you want to run just one of the streams or both streams. So this one is the service config test, and this one is the service, the performance test. I guess it will be in the next one. So the performance test and the configuration test, and you can also run a throughput RFC 2544 within a 1564. I believe we're the only ones to have implemented that way. So for example, let's say you say, no, I still believe in the RFC 2544 and I think it's a valid test. You can put like a total of the max bandwidth and it will do a real RFC 2544 throughput test inside of that configuration test. Okay? So let's go to next. And then we just say start for our J-QuickCheck to make sure everything is connecting properly, that we find a loop properly. Okay. And then we just go to next here. Okay. And then you can either do stop on failure or not, and then it will flash to you what it wants you to do next. So it's telling you should start the traffic. It's going to do the service config test first, then you'll see the performance will be done simultaneously, and then it will give you the information. So if I go here on voice, okay, it will display to you the CIR value that we're testing at right now. Okay, so as an example, it was 6.32. It's already passed. If we go to stream number 2, so imagine if you had to run this test on RFC 2544. You would have literally had to do it twice, okay, and then all 4 tests, and then different frame sizes. This one is a 1 minute, 15-second test. Sorry, less than 2-minute test, let's put it this way. Now it's completed the service configuration. It's doing the service performance with both streams. If I click on the frame loss here, let's go to overview. So this pipe view that you're seeing, someone asked about out-of-sequence count, and yeah, we do. So this is something you'll never see in an RFC 2544 test, the out-of-sequence count, which is nice. Sometimes it can be very useful to detect problems in switches and routers. So you have the information rate, frame loss ratio, round-trip delay, delay variation, and we also have availability, which is nice. This is something that's 1564 related, you know, the available seconds, up seconds, and errored seconds. So this is something you don't get in RFC 2544. Okay, so I think we're almost done with this test, and then again, it will generate a nice little PDF document for you after the test is completed, and then of course you have other options as well. So it's almost done. Let's go to next. Okay, then we go to report info. Again, you can put all the information for the customer info, so the logo. Go create the report. Okay. Okay, so I'm going to let that report generate. And while this is generating, perhaps open up the line for questions. Oh, somebody's asking me, what version of JDSU 8000 firmware you need to have J-QuickCheck feature? So I believe it starts at 13 or 14 firmware load. So possibly 13 or 14. If you have anything lower, you will not see the J-QuickCheck. But to be sure, I would go with 14. But today you have 18 available on the web for free. Okay. All right, so how about this, Natalia? Maybe we can, anybody else have, I think that's pretty much it in terms of what I had to present today. Of course, we have 2 more presentations that are coming up for advanced Ethernet testing, true speed testing, etc., and then further 2 more webinar series coming to you guys as well for free, so you can you know, check those out as well. We're going to be sending out, I believe we're sending out emails for that. Natalia, did you get any questions?
No, no questions. Just one again about the URL for test set upgrades, which we said we will include in the follow-up email. Other than that, I have no questions.
Okay, perfect. Do you want to open up the lines, or we're okay? So, guys, if you have any questions, of course, the chat is wide open. If you want, we have time to answer some questions. We have a good half an hour if you need it.
I cannot open the line, though.
Oh.
It's set up, so we will have to use the chat panel for the question.
Okay, folks, so we're going to have to use modern technology. Not voice technology. All right, so I guess we can wrap up pretty soon, but of course, if you guys have any questions, yeah, for sure, slides to a flash drive. Okay. Well, we're going to provide you guys the deck, definitely. We can probably provide you like a Dropbox to go get it. Okay. Thank you guys for participating. Okay, so most questions are about the slide deck, of course. Okay. You'll be able to download a copy. Yep. Yep, you'll be able to get the PowerPoint. Absolutely. So yeah, we really appreciate all the participation today, and JDSU, as you know, we love to provide solutions for you guys to save you guys some time. And of course, if you guys have any suggestions, you know, in terms of improvements, we love to hear what you're experiencing in the field as well. So please feel free. My job title is solution specialist, so I don't take that lightly. Our job is really to provide you guys with solutions, okay, not just equipment. Okay, so Natalia, I guess we can wrap it up.
Yes, we can. With this, we can close today's session, and we will see you next Monday.
Yep, we'll look forward to the next session. Thank you, guys.